We figured out the derivative of sine inverse, and now we're trying to figure out the integral of sine inverse. We can use the product rule for integrals, or essentially the inverse product rule over derivatives. However you want to think of this, integration by parts. Essentially, we have a product of two functions where one function is the derivative. This is equal to the product of the two original functions minus the integral of the product of the derivative of the other function times the other original function. So we can write it like this. So the first step to using this formula is to always identify the derivative of this first function and the original function. So considering the integral of sine inverse of x, we can let v equal sine inverse of x because we have to take the derivative of v, as you see in this formula. So we know the derivative of sine inverse of x. That's why we let it equal v. So doing so, we have the v and we have the dv dx. So the next thing to do is to figure out what is the u and what is the du dx. Well, if we want to figure out the integral of sine inverse of x, we must let du dx equal 1, because plugging it into the formula, du dx is 1, v is sine inverse of x. Well, 1 times sine inverse of x, that's the integral of sine inverse of x. So that's the setup for the beginning. So we know what du dx is, and now we can figure out what is u. So multiplying both sides of this equation by dx, we get that du is equal to dx. And now we can integrate. So the integral of du is u. The integral of dx is x. So we get this equation. We figured out what u is. It's just x. So plugging everything into the formula, we get that the integral of du dx, which is 1, times sine inverse of x. Notice that we created this, but it's literally the same thing. That's exactly why we set it up like this, to figure out what is the sine inverse of x, the integral of this. Well, what is this equal to? Well, it equals to u times v. So we just figured out that u is x, so x times v. We said let v equal sine inverse of x, so x times sine inverse of x, minus the integral of, well, u, which is x, times dv dx, which is 1 over the square root of 1 minus x squared. So we get this. Now what? Well, we have to figure out what this is. What is the integral of x divided by the square root of 1 minus x squared? Well, here we can use another substitution. We can say let u, or w, equal 1 minus x squared. So here we're using w. Now taking the derivative of both sides of this equation with respect to x, we get that dw dx is equal to, what is the derivative of this with respect to x? Well, it's negative 2x. And we can solve for dx. If we solve for dx, we can multiply by both sides by dx, and then divide by negative 2x and solve for dx. And we can plug this dx here into this dx. So doing so, we get the integral of, well, the x stayed the same. We said that the stuff inside the square root was w. 1 minus x squared is w. And the dx was negative 1 over x dw. Simplifying things, we see that the x cancels with this x. Negative and negative turns positive, and we get left off with this. Of course, we can rewrite 1 over the square root of w as w to the negative 1/2 power, like this, using exponent laws, which we've shown in another video. So we see here that the 1/2 and the 1/2 cancel, and we get left off with this. So remember, the integral of this, you have to add 1, so we get negative 1/2 plus 1, well, that's 1/2. And then we have to divide by that sum as well. So we have to divide by 1/2. So we see that the 1/2s cancel. And again, w to the 1/2 is the same thing as w square root of w. So you can write this, x sine inverse of x plus the square root of 1 minus x squared. Remember, w was 1 minus x squared. So this is the final result. So we get that the integral of sine inverse of x is equal to x times the sine inverse of x plus the square root of 1 minus x squared plus c.